This is a culmination. This is a put together lesson of using the end behavior test that there is a earlier video on, and also finding zeros and their multiplicity, which there is also a lesson on. So if you have not looked at those two lessons and you don't already know what I mean from the terminology I just used there, I would recommend going back to those. Basically what we're doing today is we're going to try and graph out functions using the end behavior test, meaning does it rise or fall left, does it rise or fall right, and finding zeros and their multiplicity so that we can graph this whole thing out, as get pretty close to being able to graph this whole thing out. So again, I would go back to those two videos if you're not sure what you're doing there. Okay, so those are the two things that we need to be able to graph this polynomial function. We need to know what it's going to do as it's going out of our sight to the left and out of our sight to the right type idea, like as it's going outside the window. And then we want to know what it's doing in between there. So we'll start with the end behaviors. We will start by finding the end behaviors. As you guys will know from watching those past notes or looking at the ones that you have, such as it is, you need to know your degree and you need to know your leading coefficient in order to be able to figure out your end behaviors. Degree is the highest exponent that we have on our variable. In this case, that would be 3, which is an odd number, since as you'll remember, the only thing we care about the degree for is it even or odd. Leading coefficient then needs to be the number in front of the x to the third, which would be this usually invisible one that I went ahead and marked out here, which means we have a positive leading coefficient. An odd degree function, well, I know with that I'm going to have opposite end behaviors. Right, I know if it's rising on one side, it's going to be falling on the other. Since it's positive, that means it's going to be trending positive as it goes from left to right. I mean, it's going to be trending up. So that would imply for my end behaviors that it's going to be falling to the left. It's going to be going down on the left side, and then as it goes from left to right, as we read the graph from left to right, it's going to be trending upwards. So it's going to be rising as it goes out of sight to the right. Those are going to be our end behaviors here. That is useful information, but just like on the notes with end behaviors, that doesn't tell me everything I need to know. There's still what's going on in between, like in the part that we can actually see. We want to know what's happening there as well. Well, to do that, we're going to need to find the zeros. So that's what we'll do next. Remember, zeros means the same thing as x-intercepts. And the way we find x-intercepts is by plugging in 0 for y. That would mean we'd have 0 equals x to the third plus 4x squared plus 4x. And the way we want to solve that is by factoring. The first thing you should always be looking for with factoring is GCF, greatest common factor. In this case, we do have a greatest common factor. It'd be x. So we're going to pull an x out of everything in this function. I'm not done factoring though, because now I see that what's left inside the parentheses is something that I can also factor. I just need to find two numbers that multiply to 4 and add to 4. Well, 2 times 2 is 4. 2 plus 2 is 4. So that works out well. That means we've got the x that we pulled out, and we've got an x plus 2 squared, or an x plus 2, depending on how you want to write it, assuming that your teacher doesn't have a preference one way or another, which I do not. So we want to set each piece equal to 0, which would be x equals 0 and x plus 2 squared equals 0. Remember, we can do that using the zero product property. X equals 0 is kind of already solved out. There's not much more to it. It's just x equals 0. On the other side over here, we're going to get x equals negative 2, because you just square root and then, subtract 2 over. I don't think that's too terrible. So we have two x-intercepts. We have two zeros, it looks like. But now we also want to determine the multiplicity of each of them. Well, x equals 0 I found once, no exponents, no repeats, nothing like that. But the x plus 2 squared, now remember, we just said out loud, x plus 2 squared means you really had x plus 2 and x plus 2. Well, if you set those equal to 0, you would get x equals negative 2 twice. We don't need to show that because we're only going to put it on the graph once. You can't really put a dot on top of another dot and have it be useful. But that does mean its multiplicity is 2, because multiplicity is legitimately just how many times did we get that answer. It's a number that tells us how many times that number was found, that 0 was found. So remember, the reason why we care about multiplicity, if you have an odd multiplicity, like 1, that means it's going to cross. Whereas if you have an even multiplicity like 2, that means it's going to touch. The graph is going to touch at that 0. So what that means is, if we say we want to graph this function, first thing I'm going to do is I'm going to mark out my x-intercepts. Here's one at 0, 0. 1, 2 out to the left. Here's my other one at negative 2. So I've plotted both of my x-intercepts. This x-intercept right here, this x-intercept right here, I've plotted them both. Okay? Now I want to look at my end behaviors. My end behaviors were that it's supposed to fall to the left and rise to the right. Well, in that case, I'm going to look at my leftmost x-intercept, which is negative 2. I'm going to have the graph fall. Sorry. I'm going to have the graph fall as it goes left. I'm showing that as it goes out of my sight there on the left side, it's going down. It is falling. Likewise, it's supposed to rise on the right. So from the rightmost x-intercept, I'm going to have it rise. As it goes out of my sight, it's going up. But now the question is, what's the middle of that graph look like? Well, at 0, it's supposed to cross. Right? We said right here, when we found x equals 0, its multiplicity was 1, so it's supposed to cross. Whereas at negative 2, it's supposed to touch. So, x equals negative 2 is right here. That means since the graph was starting below, it's going to hit this x-intercept, and it's going to go back the way it came. It is not going to cross the x-axis. Well, at some point, it has to come back to intercept with the other point. So I have it turn back. And then look what happens right here at x equals 0. The line crosses right through the x-axis as if it wasn't even there, just like it was supposed to based off the multiplicity. This is what the graph of that function would look like. So you have graphed this function. Another example, just real quick here. Let's say we had a function like x to the third minus x squared minus 9x plus 9. So end behavior, actually, let's switch all those signs. Just for argument's sake. So if we want to find the end behaviors for this, first thing would be to look at the degree as well as the leading coefficient. Degree of this is 3. Leading coefficient would be negative 1. That means I have an odd degree just like last time, but this time I have a negative leading coefficient. So that switches up our end behaviors. Now it's going to rise to the left and fall to the right. Feel free to pause if I go a little bit too fast on this example. You just want to think about what's going on here. Once I've determined that, the next thing I want to do is find the zeros, which is really the same thing as x-intercepts. To find x-intercepts, you plug in 0 for y. So that means I have 0 equals negative x to the third plus x squared plus 9x minus 9. So, I have 4 terms. There is only one method that I'm aware of for factoring with 4 terms, after looking for a GCF, which there isn't one, and that would be factoring by grouping, where we put parentheses around the first 2, put parentheses around the last 2. I am going to pull a negative x squared out of the first parentheses, which would leave me with x minus 1. And I'm going to pull a 9 out of the second parentheses, again leaving me with x minus 1. And since those are the same, I can pull that x minus 1 out as a factor, and I can also have negative x squared plus 9 as a factor. So, now that I've factored, I can set each piece equal to 0. First one's pretty easy. I just need to add 1 over to get x equals 1. Second one, if I subtract 9 over, I have negative x squared equals negative 9. Then I need to divide by negative 1 to get x squared equals positive 9. Then I need to square root. Now do not forget that when I square root, I have to add a plus or minus to account for the ambiguity, since I don't know what x is, and both positive and negative numbers squared give me positive answers. So I'll just go ahead and pull this down, the same line. That's great. We have x equals 1, x equals 3, and x equals negative 3. Meaning we actually have 3 x-intercepts, 3 zeros this time. We also need to determine the multiplicity of each of these. Now, 1 has a multiplicity of 1. I think we probably all would have been fine with that. On this one, generally, because of this x squared, you would think the multiplicity would be 2. And you would be right, except when we square rooted, we had the plus or minus. And so now, that x squared got split because we have an x equals 3 and we got x equals negative 3. So that exponent that would have given us a multiplicity of 2 gets split the same way the 3 and negative 3 did, so they all end up with a multiplicity of 1. It can be a little confusing, but if you think about it, hopefully that'll make sense. At any rate, we are able to graph this function out now. Let's see, 1, 2, 3, there's negative 3, 1, 2, 3, here's 1, and positive 3. My end behaviors that I found earlier say I'm supposed to rise left and fall right. So on my leftmost point, I will have it rise, and my rightmost point, I will have it fall. All of these had an odd multiplicity of 1. Which makes it much easier, because that means it's supposed to cross through every single one of them. So, there's cross through, there's cross through, there's cross through. Graph crosses the x-axis at all 3 of those points, and behaviors match up with rising left and falling right. That is my graph.